Hi, Wasim here. Hi Suhas and for Sharath as a guest. We have been privileged to have you, dear students. So this is the Reach Out Season 1, Episode 1, which is the alumni interaction. Actually, it was started a few years back. In between, we are just continuing it. So by naming it as Season 1 and Episode 1, we have coming much more episodes with different alumni. Okay, so here is the Season 1, and which is called as Episode 1, which is on experiences and research opportunities in the USA. Okay, so delivered by, as you can see on the screen, he is Dr. Suhas Rao. He was our distinguished alumni actually. So he has got his BTech from our institution since from 2013 to 17. He was our BTech student. Then he has joined Master of Science at University of Illinois at Chicago in 2020 and has pursued even PhD at the University of Florida in the year 2024. Okay, so now currently he is working as a postdoctoral associate at University of Florida. So during his master, so he worked on like fluid mechanics and also focusing on studying these oil spills in the ocean. And in the PhD, he has studied the phase change heat transfer and investigating the physics behind the pool boiling crisis. Okay, so currently he is working on developing the thermal management solutions for emerging electronics. So with a focus on data centers. So here is the brief introduction of Dr. Suhas. So now I am uh, handing over this session to take over to Suhas. So Suhas, is that okay?
Yes, sir. That's perfect.
Yeah,
And thank
I
you for
just
that kind
yeah, yeah,
introduction.
and thank you. And I just stop presenting so that you can share your screen.
Yes. Um, I think I do need oh yeah, okay. So I'm going to uh give me 1 second.
So in the meanwhile, you set this up. I just want to add one more other thing, which I came to know recently that Suhas is now going to join Tesla very soon. So that is another biggest achievement I can say, and we are going to see him very soon with a new badge in his career path. So that's interesting. Please continue.
Yeah, definitely. Yeah, thank you, Wasim sir and Varun sir for the kind introduction. Hello everyone. It's very nice to see a lot of people on the panel today. I think Wasim sir gave a very nice introduction of me. I will also, in the next few minutes, sort of keep talking about my experiences during undergrad and BTech, and then how those experiences sort of shaped what I wanted to do and how I wanted my career to turn out. And I think Wasim sir and even Varun sir and I, we sort of decided. I think we definitely want to keep this a lot more interactive than just me talking a lot. So feel free at any point in time to just interrupt me if you have any question or clarification, and we can take it from there. I don't know how many people can raise their hands on the thing, maybe through your Teams link. Can people just raise their hand if they're interested in fluid mechanics or heat transfer? Maybe you can do that through the Teams thing. Okay. Yeah, I see Shivani has raised her hand. Anyone else? Okay, that's great. Yeah. So at least two or three people that I see have raised their hands, who are interested in fluid mechanics and everything. That's the route I took. Anybody interested in robotics at this point in time? Something that interests you, maybe robotics or automobiles. Yeah, that's great. I think I see some more hands go up. And anybody interested in heat transfer? Okay, that's good. Yeah, at least we have a good mix of people. But essentially, what I wanted to sort of today talk about is uh, you don't really have to restrict yourself in any way. There's ample amount of opportunity out there to go and explore. And I think what I hope to, at least by the end of this talk, sort of maybe tell you is I have had the opportunity, sitting where you are sitting just a few years ago, right? 2013 to 2017, I was basically in the same position that you are in right now. Uh, and I've had the opportunity to explore opportunity various industries, and that's exactly what I wanted to sort of talk about today. So as Wasim sir mentioned, I started my BTech in 2013. uh, some of the highlights that I've put here in terms of what I did during my BTech was a lot of automobile things. So I was part of the NKRC go-kart team that went to Pune. I have some pictures from that I can show you. But most importantly, I think internships during my undergrad really helped me a lot. So I actually did close to 3 internships during my BTech. One of them was in the sheet metal industry. They were essentially making these window frames. And what I got to really experience at that point in time, I didn't really understand a lot of things, but what I got to really experience was how does an industry work? What is an assembly line? How are these processes refined over a period of time? So they were taking these stainless steel sheets, stamping them on an assembly line, and essentially making these really nice, beautiful modular window frames that you actually see. And that was one of my internships. The second internship that I did, I think during my third year, was in Bharat Dynamics Limited. As you all know, it's part of DRDO, a defense organization, which is government run. And what I was doing for them was trying to optimize a CNC G code so that they can essentially manufacture a small part a little bit more effectively than what they were doing in general. So again, that sort of told me that and the most important thing about the defense industry, what you'll realize is they don't care about efficiency as much as they care about precision. They're probably making only 5,000 missiles a day, I mean an year, but all of those 5,000 parts have to be perfect. There cannot be even a small defect in them, because so much is at stake, right? If you're trying to fly a rocket, for example, Elon Musk and everything, even a small mistake out of the 10,000 different processes can essentially result in catastrophic failure. So that is something that that internship taught me, the importance of. And if you get into maybe depending on where you are, maybe fourth year, you essentially have a industrial engineering course where you start learning about these Six Sigma processes and things like that. What I really learned was some industries are governed by those strict standards. I think that is something that that internship taught me. And then what you see here, I think I will try and turn on a laser pointer if that helps. What you see here was third internship that I did. It was actually for an engineering firm called Satyam Venture Engineering Services Limited. And they were vendors to all the OEMs are original equipment manufacturers, like BMW, like Mazda, ZF and TRW. Essentially they make the original equipment that goes into any of your cars. So if you look at BMW or any of the luxury cars, I mean, it doesn't have to be luxury, but any car, these companies essentially make those parts for them and then fit them into the cars. So what I was doing was, I can talk about it slightly later on in detail, but essentially I was trying to optimize their head restraint guide rods, and I'll talk about that just a little bit. Um, later on. And then, that again taught me what it is to work in a very corporate environment. They had, very strict deadlines about every month or every 2 months, they had deadlines. I was only there for about 4 to 5 months, but that definitely taught me a lot. But I guess the takeaway point here is, BVRIT really gave me a lot of opportunity to explore outside of the classroom. And I think that really, really shaped my interest at that point in time. What you learn in the classroom is obviously very important. But what you learn outside of the classroom, I feel has tremendous amount of value, because until and unless you see something and touch and feel it, and you are doing it on your own, it's really hard to get an intuitive feeling for what is in the classroom. I still remember Varun sir used to teach us material science, and these eutectic flow diagrams of different alloys and all of that. It was all good in the classroom, but then once I went and actually started doing this internship, they were starting to explore exactly this thing. How do these what can we make these materials out of to increase their strength? What should be their grain sizes? If you don't make them a certain way, if your quenching process is not accurate, how does that result in defects? And that, when you really see that right in front of your eyes, you can really connect back to what you learned in the classroom. So I think that was a very big takeaway for me from that particular experience. Is internships will definitely teach you a lot. And if you have the opportunity, I would say definitely take up at least one or two internships during BTech, or just get involved in project outside of classroom. And I'm BVRIT, I know it's great things are going on, so you're really in a very, very good position to explore your career on your own. And then I sort of moved on to get my master's at University of Illinois Chicago, and I was really interested in a lot of fluid dynamics at that point in time. I started taking one or two fluid courses, and then what really interested me was the fundamental research that was going on in there. And what you see here is not actually a simulation; it's an actual oil drop that is sitting on top of a liquid surface. And if I start playing this again, so essentially what's happening there is, when the oil drop is coalescing with that liquid surface, it's not happening in one step. It's taking multiple steps to actually coalesce with the surface, because uh, of capillary forces. The capillary surface tension forces that are acting on that oil drop, they're essentially pinching away a certain volume of the drop. And this is exactly what happens in oil spills. And why is that relevant? Because let's say you have an oil spill, and I'll talk about this a little bit more in detail again. Like I said, I don't want to get into too many details now, but most of the relevance for all the research that I did during my master's were related to ocean sciences, environmental engineering. ExxonMobil was very interested in the research that I was doing, and I'm going to tell you a very nice story about that. And beyond that, also pharmaceutical industry. So there is a lot of relevance to these kind of oil water interactions in emulsions, right? So pharmaceutical industry was pretty interested in that. And then I moved on to, again, at that point, what you see here actually is a little bit of fundamental heat transfer. Uh, you're essentially seeing a surface of dry ice, which is at negative 72 degrees Celsius. And if you start dropping different fluids, so this is water, this is hexadecane, this is hexadecane, this is dodecane, and this is pentadecane. Uh, don't worry about the names, but essentially they were all dropped from the same height, but they essentially rebound to very different heights. And that's happening because of the thermophysical properties of those particular fluids. What you are probably seeing here is, as it's coming in contact, some of those drops are freezing because of their thermophysical properties, and some of them, and water is not. Water is really such a nice fluid, that's why. And so this is getting repelled very nicely up to a very nice high height, but some of the other ones are not. So this was a lot of fundamental heat transfer that I was doing that, got me thinking maybe I should shift my focus to more heat transfer applications. And so during my PhD, I started working on a lot of fundamental heat transfer that has applications to semiconductors, consumer electronics, automobile industry, you name it, right? Like heat transfer is used in nuclear industry. In fact, I forgot to mention that here. And some of our, research that we did and papers that we published, they're actually very relevant to nuclear industry. And so over the next, maybe hopefully 30, 40 minutes, I'm definitely going to keep talking in detail about all of this. But I guess before I, jump into details, like, does any of this seem exciting to you? Can you sort of raise your hand if any of this or at least one of this started seeming exciting to you? Do you sort of like research or um, okay, let's do this. How many people want to eventually get an industry job? Let's say like me, uh, after their BTech or some graduate studies and things like that. Okay, that's at least eight people who have raised their hands. 10 people. Okay, that's great. Yeah, that's definitely cool. And how many people want to become get into academia like Wasim sir and Varun sir? Okay, that's good. There is a good number of people at least trying to do that. So anyway, I'll keep continuing. Oh, that's a cool video I took. It's essentially a mix of an air bubble that is on top and essentially a little bit of oil that is on bottom that is sort of bursting, and that became our icon for everything. Anyway, like I was saying, a lot of internships and everything during BTech. This is a cool picture that I found from 2016. No points for guessing who the driver was at that point in time on the go-kart. Very stylish driver, but we built our own go-kart. I think you might be, in certain teams. The SAE Baja team is a very nice team to be on. I think this was a Greek name that we chose. That is basically a horse that was if I'm not wrong, I think it was Alexander the Great's horse. I'm not too sure. But anyway,
Alexander's horse,
so
right?
sorry, go ahead.
You're right. That was Alexander's horse's name.
Yes, absolutely. Yeah. So I remember we chose the name based on that.
It
And
was
then,
Bucephalus, I think. Yeah.
that's right. That's exactly right. Yeah. So that was a very nice experience for me. Again, we built this from scratch. So think about everything that needs to go into this, right? We had to design our own things. I think at the end of it, at least two or three people, uh, we basically became experts in welding because we could not weld at the start of it, but then we practiced and practiced, and we definitely became experts at welding these things, all the chassis components and all of that. And I was also handling with one of my classmates here, Lakshmi. Um, we were handling even the business model for this. So it doesn't just teach you just the technical aspects of this. We essentially had to make a business model to say that, this is the cost of all the materials, how can we actually essentially manufacture this if this was, going to be in the industry and, sort of sell it as a car. And so that was also very interesting to us. I see that hands are raised. If you have a question, please go ahead. If you don't, maybe I'll just keep continuing. Maybe, okay, maybe they're just
before what you asked for.
survey. Yeah, awesome. Yeah, so great. And then I was working on a lot of, like I said, one of the internships that I had was trying to look at, I think this was the BMW head restraint. So what I was studying was if, let's say, there was a rear end collision on a particular car, what people experience, what passengers experience is something called a whiplash effect. So if you have, if you think about bungee jumping and things like that, there's essentially, it's almost, I mean, it's basically what it is called, right? Whiplash. So if you try and whip a certain leather, lash or something like that, there essentially is a recoil force, and that's what happens to your neck when there's a rear end collision. So imagine you're at halt, but someone hits your car from the back. Your neck essentially stretches to the back, and almost 20-30% of the people who are in these accidents have chronic whiplash symptoms for the rest of their life. They essentially have to, it's almost as if sleeping in a very bad position and waking up and having those muscles hurt, and imagine just living your entire life like that. So we were trying to optimize these guide rods inside that head restraint, and essentially see what, I mean, probably what you see here is at different positions. So if it's at a tall person that's sitting, maybe, or a short person, I should say, maybe it's at a lower position. So how does the stress inside these guide rods affect the whiplash effect, and the force on the human head? And so sort of optimize these designs. I think eventually, they used it actually in their design. This was for a Mazda component, and then also BMW wanted to use this. So that was again very interesting. You essentially start realizing what are all the tiny things that go into designing a very, very complex, product such as a car, right? I learned so much about safety in a car. What does, if you're, for example, I guess, if you have, uh, if you're trying to pull your seat belt in when you're, at least in any of the new latest cars, maybe in the last 5 to 10 years, if you pull it rapidly, what you'll see is the seatbelt actually gets stuck. It does not actually, come, and you cannot actually plug it in. So only if you pull it slowly, you can actually put your, seatbelt properly, buckle yourself in. And the reason for that is there's something called a pretensioning. What that means is if a car suddenly experiences a jerk, you are actually going to move very rapidly, and the seatbelt should not actually, just randomly loosen up, right? Otherwise, you're going to hit yourself onto the front. And so it automatically knows to, tension up, and that's what holds you back inside your seat. So there's these minute technology that goes into, the safety of a simple car, right? And, so many industries have worked on this. Um, and of course, I have some really outgoing memories from 2017. I think Murli Krishna sir, he was our class teacher at that point in time. He was also the head of department at that point in time. We, got some cake and we printed out some T-shirts with all of our faces on there. For some reason, I couldn't find a lot of other pictures, or maybe I was slightly lazy to go back to Google Photos. But definitely a lot of good memories, fond memories. I've made, friends that, friendships that I know will last a lifetime. This was mechanical engineering B. This was basically the last day, and this was, I think, the new cricket, ground that was built beside the library. This was just built at that point in time with all those, seating. So this was very fresh. I think this was built just maybe 2 weeks after it was built. We took this picture near the lake and everything. So I know the campus has changed quite a bit after that. And then, I started my, master's at University of Illinois, Chicago. Somehow, I was working with a team there were a lot of Indians. This is Varun. He was a postdoc when I was there. He's now at Harvard. He's pursuing an academic career himself. All of these people actually, so we were all master students at that point in time, and all three of us eventually, ended up pursuing our PhDs. So I think Nikhil, he's still doing his PhD. Yash and I, we graduated just this past, May and August. Again, we are all in, completely different universities. I went to Florida, he's in Pennsylvania, and he went to Virginia Tech. So the reason I, put up this picture even is to sort of show you, what even a laboratory setting, you already know what, BVRT labs look like, what sort of opportunities you have there. This was a fluids lab that, we were working on all those oil spills and things like that. And what we were essentially doing was simulating how an oil spill will happen, but we were simulating it on a benchtop experiment. And you might think, how can you ever simulate something that is so big on such a large scale, on such a small space, right? And it turns out scaling laws of, uh, observing something really small and then extrapolating the same insights to such a large scale is always possible. And I think that is something that this lab taught me. Uh, and this was the first time I was, building my own setups, experimental setups, running my own experiments. So it gave me a lot of, and one thing that I want to mention is it's not going to be easy. It's not going to be all, we're obviously smiling in this picture and everything. But there were days, I used to work roughly, 10 to 12 hours a day in the lab, spending a lot of time. But then it eventually turns out to be very rewarding because you definitely, what we found out, my thesis and everything, I'm really proud of what we did at that point in time. And so, uh, depending on what you like, for example, right? I had a friend right behind this wall. Actually, there was a robotics lab. So I saw a lot of hands come up when there was robotics. And, there's a lot of cutting edge research that typically goes on in, some of these universities. And one thing that I, again, wanted to emphasize was, I really want to talk about research opportunities, but one side thing is if a lot of you are interested in, let's say pursuing, graduate studies, uh, it is totally worth, spending a lot of time and effort building your profile and resume to try and go to the best university that you can go. There is a very marked difference between some of the top tier universities and the opportunities that they will provide you versus some of the lower ranked universities. You may not get the same kind of opportunity. And to just draw an analogy, is the same as going to BVRIT versus maybe a lower ranked college. You may not have access to all the opportunities, all the networking connections that sort of help you get to where you want to go. For example, I know I met Varun. He got his PhD from Purdue University. So I made a lot of connections and grew a lot of network at those places. And in fact, some of them are collaborators now on a completely different heat transfer project. So the importance of the network and the professional relationships that you build along the way are very, very important. I think that was something this lab taught me, definitely. Anyway, what we were essentially studying was, and this is actually part of my thesis slide that I put in, every year, roughly 400,000 or 4 lakh gallons, which is, you could call it about 8 lakh or 10 lakh even liters of oil is spilled into the ocean because of some kind of tanker spill or a pipeline spill or something like that that happens. And if you remember, in 2010, maybe it's a while ago, maybe some of you don't remember, uh, there was a huge spill across the Gulf of Mexico in the US, which was the BP oil spill, where uh, millions of gallons actually spilled into the ocean. And I think just until 2022, the US government and BP was still spending money trying to clean up that oil spill. So these have very, very significant and catastrophic consequences, once that happens. And the reason I wanted to sort of put this slide up and even the next one is to show you that as mechanical engineers, we are actually needed in many more, fields than we think we are needed. Don't initially when I was, doing my BTech, the only thing if I, the reason I wanted to take up mechanical was I was interested in automobiles. I loved cars, things like that. I still remember there were these mechanics, or Lego sets, right, that you used to build all these small equipments from. That's what I was interested in as a child. A little bit of space, aerospace, I was definitely interested in, but those are not the only fields. Mechanical, if you a story that I, promised I'll tell you was when the BP oil spill happened, mechanical engineers from Purdue, they were actually specially contracted by the US government and a national lab here in the US called Sandia National Labs. They essentially flew down immediately. They assessed what is happening inside this oil spill, and mechanical engineers, solved this problem, not anyone else. So, mechanical engineers are needed in many more, fields than what you think there might be. So, here what I was showing was if there's a tanker that's going, there could be oil that's spilled here, or if there's a pipeline burst, somewhere under the ocean, that is also, spilling. So essentially, we were studying all of these processes. And what we wanted to study was how do these oils actually spread on, these ocean surfaces. And what that will tell us is if we are actually, if these oils are actually spreading at a certain rate, then how can we, employ mitigation strategies to, sort of solve these and clean up these oil spills? Beyond that, what you'll see here, right, like food industry, this is, I think, a vinaigrette or a mayonnaise, for example, how it's made is just this mayonnaise is essentially oil and water that you whip it up. If you actually do that, that's what, is so in the food industry and the cosmetics industry, people are actually trying to enhance this process so that they can uh, uh, have a better emulsion. So, for example, if you probably open up maybe peanut butter or Nutella jars, what you'll see is there's a small layer of oil that sometimes sits on top. That's actually bad in the food industry because they want it to, remain as an emulsion for a long period of time. And there's a process called Oswald ripening that happens that actually separates this, oil and water. So in some industries, you don't want oil and water to mix, like the oil and gas industry. In some industries, you actually want them to mix very well. So the fundamental insights into all of this will, sort of inform many different, industries as well. And here, yeah, this is essentially what we were studying. These are all images from my experiments. What you see is there's different oils that I deposited on a surface of water, but they're all showing completely different behavior. And the reason for that is, and this is again the top view, the reason for that is their viscosities are drastically different. So in a, let's say a tanker spill or something like that, you're not going to have the same kind of oil, excuse me, you're going to have oils with different viscosity. So they will start behaving differently. And what you'll see here is they also spread at a different rate. So these experiments, they're essentially governed by something called the Ohnesorge number. Again, I don't want to get into too many details, but basically there are fundamental fluid dynamics numbers that essentially govern these processes. We were studying how they spread, and we sort of came up with these kind of and these are all experimental data points, these spreading laws that can govern these processes. So I was essentially studying, there is a oil that spreads actually to a maximum, then recoils and then comes back, and then there's another oil that just spreads to a maximum diameter normally. And one thing that was really interesting for us as mechanical engineers, I always kept thinking, like, how can I relate this back to sort of fundamental mechanical engineering that we studied, right? And what this looks like to you actually is, okay, I won't go into all of those details, but what this looks like to you essentially is like a spring mass damper model. So the oil drop is actually spreading very similar to if you have a spring mass damper system. So the mass of the drop is essentially the mass of the weight that you're using. The surface tension of the drop itself is actually acting as the spring here. It's sort of pulling it back, and then the viscosity is acting as a a capacitor or a damper essentially. So you can use fundamental differential equations. Again, don't want to go into details and start modeling these. I'm going to skip. These are some slides from my thesis presentation. But we see that you can actually model all these oil spills, like as if these were all spring mass damper models. So, okay, great. Uh, by the way, feel free to, sort of pitch in or chime in if you have any questions at any point in time. But essentially, my whole idea of, trying to show all of this is I never knew before, joining this lab and working on all these experiments that ocean engineering, environmental science actually requires, mechanical engineers on such a intensive, projects where we have to actually go and solve these problems for a lot of industries. I defended my thesis, my advisor, Professor Sushant Anand, and then again, I switched gears to go and study a lot of heat transfer in at the University of Florida. This was our lab again. It looks a little bit messy, but this was my experimental setup. One of my experimental setup. I worked on quite a bit of projects. But the other thing that really, University of Florida or my PhD gave me was if you take any of your phones right now, right, they're completely filled with a lot of chipsets that are made. How are these chipsets actually made, right? Let's say Apple or Samsung or Google, they're designing these chipsets and they're essentially sending them out to something called foundries. So there are companies like Global Foundries. You might have heard of Taiwan Semiconductor Manufacturing. Yeah, I think you're muted, Dr. Varun. Yeah. Yeah. But basically, TSMC, all of these companies, they start manufacturing these things. And I essentially got to uh, do all those processes inside the clean room. So that is why I'm wearing all these suits. It's almost like wearing these PPE kits during pandemic. But we have to do that because we cannot let even a small strand of hair, for example, affect the manufacturing process. So I was building all these chipsets, and we build those chipsets and then perform the thermal analysis on all of these things. And these are all sort of slides I use to motivate electrical engineers. As we are, going from 1985 to 2020, the power inside all of these chipsets are actually growing very, very rapidly. At the same time, they're getting smaller. The fabrication resolution is actually getting way smaller. Samsung, I think, released the 2 nanometer chip and all of that. But where does all of this thing come from, right? Let's say, I'm sure, actually, let's do that as a survey. How many of you have used ChatGPT at some point in time, in the last year, for example? Can you raise your hand? Okay, at least, okay, a lot of people. That's nice, yeah. So a lot of people, right? At least. So you'll be surprised to know if, let's say, I have a 10 to 15, question conversation with ChatGPT. You obviously keep asking and then it responds and all that. Eh? So about a 10 to 15, question conversation, if you have, trying to find, it basically takes up, oh, maybe I should not blur my screen, but it takes up about half a liter of water to essentially keep those chips running. To keep those chips cool. That's the amount of water that is being used in these data centers to actually for you to keep using ChatGPT or scrolling Instagram or something like that. So the data center industry right now is seeing a huge boom in electronics engineering and mechanical engineering, where a lot of innovative things are happening in the mechanical engineering space to essentially make these data centers a lot more efficient. Think about the amount of massive power that goes into these things. Right now, I think data centers consume about like 3% of the total world's electricity. So these are all huge, amounts of electricity where mechanical engineers have a lot of opportunity to come in and make these facilities a lot more efficient. And that's essentially what I've been working on, basically the last 4 or 5 years. And what I'm showing here is uh, how a traditional data center is, cooled. So how it's cooled is how all your, classrooms are cooled essentially. They just, pump a lot of huge amounts of cold air and hope that, these chips remain, below that 80 degrees Celsius that they need to. So if the chipsets actually cross 80 degrees Celsius, they start failing because of semiconductor, they start burning out. So that's how they're cooled. And roughly, so think about this. This is, something, this is my favorite chart that I always use to sort of pitch to investors and everything. Roughly 50% of the energy that's flowing into a data center is used not to power the chips. It's actually to keep the chips cool. So imagine how much opportunity we have as mechanical engineers to go and reduce this. And our goal essentially is to reduce it to roughly 2% of the entire, data energy usage inside a data center, right? And that this gives a different kind of, let's say, opportunity, right? I want to talk about research opportunities, but essentially, one thing I wanted to mention here was through this entire process, I've also been exposed to a lot of entrepreneurial skills and opportunities. So the technology that I developed during my PhD, investors were actually interested in this, and we had, and I think we still have the opportunity to commercialize this technology and build your own startup. So, if any of you, can we maybe, how many of you want to, let's say, start your own company, maybe after BTech or maybe after a little bit more formal training? Do you want to raise your hands? Or maybe some of you are already doing it on the side. Yeah, this is all great. At least 2 or 3 people. Okay, that's nice. 5 actually. Okay, that's good. Yeah, so this is great, because for me, this kind of exposure to, essentially pursue different paths, right? At this point in time, I could have chosen to become a professor, teach all these things. If that's what you're interested in, that's what you can choose. If you want to go into the industry, you can choose that. Uh, or if you want to start something of your own, if that is what really excites you, building products on your own, that is something that you can pursue as well. Uh, what I was showing here was essentially, there are all these chiller units that can be eliminated if we essentially use, liquid cooling inside these data centers. And this is something that you'll probably keep hearing very soon. Um, Again, I don't want to go into all the technical details, but yeah, basically, a lot of mechanical engineering here as well, and biomedical engineering as well. So can you think of, can anybody, uh, maybe point out one case of liquid cooling that you see in everyday life? One of the most powerful computers is actually liquid cooled without actually being air cooled. And does anybody want to maybe take a guess at least, what it might be? No? Okay. So it's actually your brain. Your brain is doing, millions and millions of computations, neurons and synapses every second. And essentially, it's as good as or it's actually twice or thrice as powerful as like an NVIDIA GPU, for example. But you're not, putting, huge amounts of fan or anything that's to cool it, right? You're just using your blood circulation to essentially cool it, and all that heat is being taken away through sweat and everything. So these are all interesting things that come along the way, and then sweat and liquid evaporation, these are all cool things. So you may not realize that mechanical engineering, heat transfer is there in many different fields. But one of my friend that I showed you earlier, he started working on heat transfer in biomedical systems. So essentially, looking at how your body retains heat. So these are all industries where, people could be involved in as mechanical engineers. And maybe I should really skip these parts and we can talk about other things in detail. But essentially, we were, proposing a new sort of a heat sink where instead of having a microchannel heat sink, you essentially have a membrane that removes vapor and all of that. So again, I don't want to get into too many details. Let me keep going quickly over this so we actually have some time to interact. Yes, sir. Oh, okay. Um, but you showed, we basically showed like 10x the performance, and the opportunities in terms of research opportunities are uh, in the US. Fundamentally, there is. Sir, do you want to, chime in, Wasim sir?
Uh, Suhas, I think your video, I think it's stuck. Your
Okay.
presentation is running, no problem. So your video, I think it's not moving along. Yeah, now it's okay.
Okay. Okay. Yeah, I think it's taking too much bandwidth. Yeah. Okay, great. Uh, but essentially, one thing I wanted to mention here, I'm just talking about my own research, but the way, US research essentially works is the government invests a lot of money into actually academic institutions rather than industry to, develop all these fundamental insights into what will become technology, let's say 5 years from now or something like that. And so that essentially gives us a lot of opportunity being inside a university. It gives us a lot of opportunity to essentially work on the cutting edge of things. These, what I'm showing you here actually is, I don't know if I can, oops, is, these are high-speed cameras and each of them, cost at least 40 lakh Indian rupees, for example. But because the funding in the US is, the government invests so much amount of money into universities that I was able to essentially procure all this equipment, uh, build some cool setups. The clean room environment actually costs about roughly it costs about $1,000, so $10,000, just to make a single device. So what I'm trying to get at is there's a lot of opportunity to work on the cutting edge of things. Whatever we did will probably be used in the industry like 5 years down the line or 10 years down the line, and that is definitely an awesome opportunity to build things for the next generation essentially. Again, this was a lot of fundamental work. I don't want to get into the details unless you really want to dive into it. But this is what I was talking about in terms of nuclear reactors, right? We essentially showed that with a little bit of design changes inside your heaters, you can essentially get roughly 4 times the amount of heat from a particular let's say nuclear reactor. And if you remember, I think this was in 2009, there was a big nuclear disaster in Japan, the Fukushima nuclear plant. Essentially, what happened was the nuclear fuel rods started burning down and they started overheating. And sometimes what happens is the heat is so high that water cannot even come in contact with the nuclear fuel rod, and because that cannot happen, it just builds up and leads to like catastrophic failure again. And something very simple, maybe it's dinner time in India, maybe you should try this. Just take a dosa pan, and everybody does this, right? So if you take a dosa pan, if you're putting some dosas or rotis, uh, put it on your gas stove, start heating it up. At some point, maybe just put one single drop of water and it will, normally, evaporate and everything. But if you wait for a long time and let it heat up for a long time, and maybe you should try this definitely today. And if you put a drop of water, it'll start dancing on top of that pan. It's going to start crittering and dancing on top of the pan. And what's happening is the water drop, the heat from the pan is so high that the water drop is not able to come in contact with that pan. And basically, there's a vapor cushion that it's forming below that water drop. And so it's acting as something like a hovercraft where it's, dancing on top of that vapor cushion. And that is exactly what happens inside these, nuclear power plants and everything. And that's what we were trying to study. And we basically showed that, that you can essentially increase. And, like I said, I keep talking about research, but the network that you build essentially is one of the strongest, your strongest assets. This was from last year. Unfortunately, I was actually attending all my Tesla interviews and everything in California, so I could not go to this year's alumni meets. But this was last year. Met RP sir. None of you might know him. He was here. He was at BVRIT when I was there. Sort of moved to the US to pursue his own career. But these are all classmates from, actually, Amulya is from IT, but I think Chandan was from Mechanical A. So, you still meet a lot of your friends from, BYD. So it's very nice to, still grow that network over a period of time. Uh, and really, I think they help in, advancing your career beyond just, what you do, in your, school or,
Boss, I
job or
think
something like that.
the girl in the red, I think it was
Oops.
CR, I think, right?
Yes, yes, she was actually the mechanical engineering, mech ACR. Yes, that's
Yeah.
right. Yeah, so she's actually in Florida. We met recently and all of that. So
I forgot her
yeah,
name. Can you just recall?
I think it is Bhavana. I'm not. Yeah, I think it was
No, no, no.
Bhavana. No, not Bhavana. I think she texted me actually recently. I'm so sorry. Even I forget very bad with names, but I will, find out in
No.
very soon. Yeah. Yeah. So anyway, that basically concludes my presentation. I don't want to, keep talking too much. I think, we should really have a much more organic discussion about these things. Uh, I really want to give you guys an opportunity to, start. Uh, it doesn't even have to be questions, but what maybe was your even feeling when, let's say, I was describing my experiences? Is this something that excites you? No, is this something that not really excites you? And I think, at this point, I know there's a lot of hesitation to, let's say, speak up in a public forum, but that is one thing that uh, I did not have during my BTech, and it definitely helped me, in terms of even anchoring some of the events and all of that. And I would really encourage you to just, give your comments on what it even is. You don't doesn't necessarily even have to be a question or something like that. So actually, I'm going to start behaving like one of the lecturers, maybe. Shivani, I know raised your hand for fluid mechanics. How does that excite you? Maybe we should actually call out people and ask them. What do you think, Shivani? Did that excite you, or what are your thoughts on this? Okay, Shivani is
Actually,
refusing to
congratulations for your
go ahead. Sorry.
means we already have a fluid mechanics subject in our syllabus copy, right? And the thing is that fluid mechanics is very easy, so that's why I was excited to.
Okay, got it. Yeah, I mean, yeah, definitely. I mean, it's pretty easy in general, and especially if you like it, it actually starts becoming even more easy. Any subject that you think is actually, can someone, maybe point out what is the hardest subject at this point in time for you?
Maybe heat transfer.
Heat transfer? Okay, yeah, yeah, that's definitely. uh, very complex. Same thing. Murali Krishna sir taught us thermodynamics and heat transfer. Definitely for me, it was also the most difficult subject. Sorry, someone else was trying to say something. I remember someone said robotics and they raised their hand. Is that basically something that people are interested in terms of like, does anyone get excited by robotics or heat transfer? Okay, yeah. I mean, anyway, we basically I wanted to sort of take this opportunity, like I said again, to very comfortably. I think one thing I forgot to do is probably give you my contact number that I will do just now. Uh, uh, I will also share it with Wasim sir and Varun sir, and then basically they can sort of share it with you if you want. But I don't want this to be just, people coming in and, talking about these things and just leaving. Uh, I think if you're serious, okay, I guess another question, and I'm going to keep asking you a question until someone at least, gets out and, starts answering, right? Because one thing you have to realize is I was literally in the same space as you guys, sitting in the same classrooms, studying the same subjects. So I don't think there's any reason for hesitation. But how many of you are really considering masters as a serious career choice immediately after this? Can you raise? Okay, at least one, two. Okay, let's start there. I mean, Bhavya and I guess 332. What is motivating you to do masters or at least pursue masters? 332, do you want to go? Oh yeah, I'm definitely going to. I will shamelessly call you guys out and ask you to give your opinions.
Yes, sir. Hello, sir. This is Nihal, 332.
Anyhow, yeah.
Uh, I'm definitely interested in pursuing masters, sir.
Okay. And is there obviously you don't have to know it at this point in time, but
Yes, sir. The thing is, I'm in presently in first year, and I don't know
okay.
much about which field to do I need to choose in masters.
Yeah.
I'm looking for it, sir.
Okay, yeah. I mean, yeah, that's definitely very nice. So as long as you have, some vision, and obviously you're in your first year, so over the years you might, be exposed to so many different things, and you'll find your, but is anybody, what would you say, Nihal, is, sort of your main motivation to pursue masters? Is it more like the job opportunities will be better in the US? Is that what it is? Or, you know, uh, you really want to get involved in some kind of research? And like I said, I don't think there's any right or wrong answer here. Just asking for your very honest opinion. Because for me, I'll go first, right? For example, for me, it was definitely that somehow maybe I was thinking that I still needed to, study a lot more. Somehow I was not satisfied with all the, thing I did at BVRT, even though, all those internships and everything. So that was my main motivation. But what is your typical motivation to, pursue masters? And both of you, I mean, I think Nihal and Bhavya, if you both can answer, that would be great.
I'm personally interested in R&D, sir, research and development.
Okay, that's very nice. Yeah. Uh, Yeah, there's plenty of opportunity there.
That is why I have joined this session, sir.
Okay, great,
I
great.
had great insights, sir. We had great insights.
Okay.
Thank you, sir.
Yeah, I mean, like I said, more than anything, I know that it's very hard, in a public forum. Maybe there's a little, you're feeling shy and everything. So, one thing I want to say is I'm very happy to even have one-on-one sessions. If any of you are interested, have more questions, that we definitely do. But yeah, Bhavya, sorry, I keep interrupting you. You probably try to talk twice or thrice. Yep. Do you want to explain why you want to pursue masters, Bhavya? Oh, I keep seeing that you're muting and unmuting your device, but let's wait for
Yeah, Bhavya, if you have
Bhavya.
any issue over speaking or your mic issue, so you can just write in the chat box whatever you wanted to say.
Yeah, that's also one more thing. If you don't want to unmute your mic and speak, I think that's a very good idea. You can just post your questions or comments in the chat. Okay. While we wait for Bhavya to maybe text on the chat or something, um, is there any other? I guess my next question is, uh, what is, let's say, right after BTech, uh, how many of you want to get, let's say, an industry job? Can you raise your hands? Okay, that's nice. So at least a few people. And okay, I think. Okay, that's very good. Yeah, so Bhavya texted that basically I am interested to join and collaborate for sustainable growth and drivetrain systems. So yeah, that's very cool because just a funny story for Tesla, I'm actually going to be working on their drivetrain. So because they don't really have a drivetrain. It's not like a conventional, car where, there's a engine and there's actually a drivetrain and everything. But even converting uh, the DC energy that is there inside a battery and converting that into AC voltage for the motors that are on wheels, that itself requires a lot of mechanical engineering. So, uh, how many of you have already been involved in some kind of a external project beyond just, the either internships or, some kind of a project that, let's say the Baja or the go-karting or something like that? Can we see a like show of hands for that?
Actually, we have a Baha team right now. Currently, they are working. I think they are all in the workshop working with this, so might be they'll be responding in a while.
Okay, sure. Yeah, yeah, that's very nice. Yeah, even Bhavya's on the Baja team and
Yeah,
everything and
we got one
368.
person there.
Yep. Okay, so 358 asks, after my BTech, I want to join in the F1 division. So what would be the oh, also okay, awesome. Yeah, so basically, uh yeah, if you want to join the F1 division for automobiles, right? That requires, I mean, you probably are already I don't know, on Netflix or something, there's all these technology videos about how F1 cars are built. The best way is, what you're already doing is to be in the Baja team. You'll learn so many things just being on the team, just working to fix the issues that come up, and fundamentally, focus more on, I guess I would say, instead of trying to just put it on your resume, focus more on uh, what you're essentially getting out of that entire experience, right? Like I said, I never knew that I'll ever use welding, for example, but it really helped me many years later. Actually, because when we join the heat sinks, they're actually copper parts. Those manufacturing processes of brazing, welding, soldering, they help me. So, but this is something I never knew that would help me when I was actually welding the chassis parts for, the go-kart team. So you never know what will come in useful years later. So I think, just keep doing what you're doing. Uh, I think the best thing is try, and today it's the age of internet, right? So you're not restricted by any particular, textbook or something like that. If something doesn't work out, there's always YouTube videos to keep learning and improving beyond just, what is there in the syllabus. And I think that's one of the biggest things is once you restrict yourself to just the syllabus and, finishing up your midterms and semester and exams, I think that really is very limiting. I think BVRT is creating a very good atmosphere where you get exposure to things beyond that as well. And, I hope you use it to the best of your advantage. All right, I think because I scared people with asking pointed questions, maybe people are not raising their hands, but I guess,
Yeah,
the only other question.
that's the typical student behavior. So no.
Yeah, no, that's okay. I mean, I don't want to put people in uncomfortable situation.
Uh,
But this is your one opportunity to just, as if you're just talking to, and again, I will also say one more thing, don't okay, what skills should I develop and focus on? Are you talking about technical skills, or I guess, I can answer both. So technical skills would be definitely understand your, how energy systems actually flow, right? For example, you can take a very basic, and we can even do this right now, right? So let's say you're doing F1, right? What are the most important things there? Are you comfortable 358 talking on the thing? We can just talk it out, or are you more comfortable just texting on the uh, chat? No, and either way is fine because I'd rather have you answer the questions than just me telling you what you should focus on.
Shiva, is there any
So, but
issue towards your with your mic?
yeah. Maybe, yeah, but that's fine. I mean, I'll quickly go through some things, right? So, what are you essentially trying to optimize for in an F1 car? You want to reduce the weight of the car. You want to reduce the drag of the car, but at the same time, uh, okay, yeah, you can't. That's fine. So, essentially, you want to increase the drag sometimes, because you want more downforce on the car. You don't want the car to just fly away. So there's a lot of aerodynamics involved. If you look at any of the, F1 race cars, actually, there's a lot of engineering that just goes on to design the spoilers and the front sort of fins on the F1 car itself, right? So the technical skills is definitely pay attention in your materials of engineering class. Now there are so many more composite materials that are coming. So what you might learn about just alloys and steels, that might be very different from the materials that are used in the actual F1 car. So people use essentially carbon fiber frames, things like that, right? Pay attention in your fluids class, definitely. You should probably at some point you should be able to very easily write down your Navier-Stokes equations, identify that this is what is the convection term, this is my diffusion term, things like that. uh, what really helps beyond that is also developing your technical skills on designing. So I know that at least when I was, a student, we were given training on AutoCAD and ANSYS, and that's what I used. I don't know if that has changed right now. Is it the same software, sir, or is it SolidWorks or something like that, maybe?
Yes, SolidWorks, Altair has the new things that we are having it. But
Yeah,
yes, preliminary
yeah.
things are Autodesk and obviously ANSYS is there.
Yeah, so that really helped me a lot. As you saw, right? Like my internship itself was on ANSYS. I actually use a lot of SolidWorks right now, more than any other thing. But it doesn't matter what specific software you use. But basically, figuring out this design for when we were doing the go-kart, that was our biggest challenge. To essentially make an entire design and model of the whole thing, and then figure out, because let's say you're putting an engine on top of the go-kart, the chassis has to support that weight, right? There has to be, springs and dampeners to give you enough suspension. So definitely pay attention in all of your, I know even in the first year, there's actually a physics lab that, basically tells you about spring constants and weights and how much you essentially should put. For example, what should be the spring constant for, a suspension spring that you use if you, have a certain weight, right? So you start with some of the most fundamental, it's called, in fact, this is something I noticed during all my Tesla interviews and everything. That is their approach. And what they call it is called first principles thinking. So you always go back to what is the most fundamental things there, right? At every point in time, F equals ma will always be valid. So in that particular system, how is F equals ma, working actually? So think about those kind of skills that you should focus on. For example, if you're designing, let's say the suspension, F equals kx is what will determine your the spring constant. K is the spring constant, x is your deformation of the spring, and F is how much force it's being put on that thing. So if you get comfortable with these kind of concepts, then they start, that gives you a lot of advantage to be on some of these teams. UF itself, Florida has a very nice racing team, and this is exactly what they work on. The other thing that I forgot to mention was if you get the opportunity, definitely look at and also focus on manufacturing processes. Right? I learned the CNC in one of my internships, and that helped me so much right now. I basically all our parts, all our experimental setups, everything is fabricated and machined on the CNC. So pay attention on the milling class when you're doing that, to see what RPMs you should use, what are the tools you should use for different materials and things like that. So and there's, yeah, I mean, I know I'm sort of saying pay attention in every class, and that definitely holds true, that you should, pay attention in every class. But um, I guess what I'm trying to hint at is you never know what will come useful. I was in a, casting, I think in second year or third year, you have a casting essentially class where you have to make these molds and then pour like hot, metal into it and, things like that. I use that a lot right now, because the heat sinks that we essentially make. So you never know what kind of uh, skill you will essentially use in future. So I think that's the only thing I can say. So what? Okay. So yeah, there's 355 who's talking about manufacturing. Should I form to? Yeah. So I'm glad you brought that up, 355. And like I said, instead of chat, if you're open to even talking, that would be great, right? But I was actually talking to one of my juniors, my junior's brother actually. I don't know if he graduated yet. He's in BVRIT. Mritul's brother, Mritul Vemula, his brother. I don't remember his name, but he was also interested in manufacturing. So Hyderabad has a lot of opportunities that way. So if you go to T Hub, for example. They have, that's their, startup incubator. But there's right opposite T Hub, there's something called T Works. And what they are actually building is a lot of manufacturing facilities with, the advanced manufacturing. So if you're looking at manufacturing, some of the traditional manufacturing facilities, that's fine. Yeah. Okay. That's totally fine. 355. Some of the advanced manufacturing facilities will actually move from traditional mechanical engineering. So we might think that, die casting, let's say injection molding, these are what will be used, and they will be used. But, uh, you know, check how much exposure you have to additive manufacturing. For example, I don't have pictures here, but some of the micro features that we have on our heat sinks, right, that we make for data centers, they're actually additively manufactured. Yes, yeah, that's okay. So 332 is essentially saying that they're actually hosting many free workshops, and that's a great opportunity to go and start just attending these workshops. So right now, I think manufacturing it is at a stage where you can essentially start printing as if you gave. I mean, 3D printing is something that everybody probably is aware, but metal 3D printing, I don't know how many people are aware of that, right? We actually do a lot of metal 3D printing inside our heatsink. So you can essentially start, let me see if I can actually pull up one of these companies. I work with one of these companies, and they're also a startup. And what they do is, give me 1 second. So this is a startup somewhere in California. But look at this, this is all 3D printed. You cannot make these structures through traditional, manufacturing, but they're so important and they're required for, and again, they're optimizing all these geometries using machine learning, right? Because machine learning will tell you what is the ideal geometry that you should have, to actually cool these heat sinks. So if you're interested in manufacturing, start looking at things like this. I'm sure T-Works or some other facility can, give you some exposure to things like this. But at the same time, manufacturing, although these are all the fancy things that are happening, in the end, for example, I'll just give you one small example of Tesla. Okay. So Tesla essentially started, machining their parts and everything for a long time. And what they realized is that actually slows down the assembly line a lot. And so eventually, one of their biggest innovations actually is, let's see if we diecast. So what they realized is, I think they can directly die-cast their chassis and let's see, gigapress. Yeah, they call it the gigapress. So the entire chassis of a car, they're just, die casting. That's unimaginable on that kind of a scale. Just imagine the size of the dies and tooling that they have to essentially make, right? So traditional manufacturing will not die down. And in fact, one of the before I guess move on to 358's question, that is one thing I wanted to sort of highlight through this entire presentation is, people keep saying that AI will take your jobs and all of that, but actually, the first jobs that AI will replace are actually the computer science jobs, not the mechanical engineering jobs. Because anything that you can do in front of a computer will actually become exponentially easier, right? So I actually, just to give you an example, right? I write my own code, and I'm able to do that because it really doesn't take a lot of skill. I just, tell ChatGPT what to do, and it writes the code. But there are some things, the stuff that we do as mechanical engineers, that AI can never actually replace. It can maybe help us and everything, but some of the core things that people are doing, it really cannot. So, I would highly encourage you to, if anybody of you are thinking, okay, we'll do mechanical, but then shift to computer science later on or something like that. If that's your genuine passion, sure, no doubt about it, but don't do it for job opportunities, and I think that's one thing I sort of wanted to get across during the entire talk is all my degrees are in mechanical engineering. and there's ample amount of opportunity, to excel and grow in this kind of field. I'll move on to, I guess, 358th question. They're asking if I want to study masters, which country is better to do? Germany is very good for mechanical engineering. Can you please differentiate? Um, so I'm not an expert on this. I think that is definitely one thing I will tell you. The reason I chose USA uh, was for multiple reasons, right? Germany, traditionally it's known for their automobile industry and all of that. But if you actually look at the supply chain, if you start looking at where, and I have a lot of friends and actually a cousin, working for one of the OEMs. But what you realize is the rate of innovation in the US is actually much higher and faster compared to what's happening in Europe in general. At least that's what some of my friends tell me. I have spoken to a lot of friends who are doing some core mechanical engineering. It's not that you cannot do it, but think about, let's say, I would look at, and I'm not, pitching for, USA or anything of that sort, but I'm just saying, think about it in terms of, the amount of opportunities that you get here. So if you do mechanical engineering in the US, like I said, you might realize during your master's that I'm actually interested in biomedical engineering, which is but I want to do mechanical engineering in, medicine, right? The materials engineering that's happening in terms of medicine is extremely amazing. Right now I can make, just a pinprick of a needle and perform an entire surgery inside a person's heart and things like that, non-invasive surgery. And that actually requires mechanical engineers, not, doctors and things like that. So you might realize that later on. So in terms of the breadth of things that you can explore, I think USA definitely has a lot more opportunity in that sense. Germany, and maybe France, they're only boxed into one specific industry of, yes, we can build cars and things like that. But, a lot of manufacturing and design is actually moving back to the US. In fact, we actually collaborate with, I should give you this example. I right now actually collaborate with Toyota Research Institute of North America, which is in Michigan. And they're doing some amazing research. You should probably check these things out as well. So it's not that I would say there's the breadth of opportunity that you have in the US is slightly more than Germany. In Germany, you'll have to be sort of limited to, let's say, only the automobile industry. There's really not much else happening. So think about all these things. It's definitely, a lot of things to consider and then take a decision. I'm sure I actually, Wasim sir probably, is probably better to, pitch in on this because he did his masters in Germany, right? So I think he's better.
No, no, I'm still in India and never visited any abroad universities. My all education is done in India itself.
Okay, okay. I thought you got your automobile engineering degree. I think, if I remember, I thought, okay, maybe
Yeah.
I must be mistaken. Yeah. Yep, and totally makes sense. I know it's getting late, so sorry. But yeah, any final questions, or we can actually close, and I will, like I said, you already have my email ID. I'm happy to take these questions later on. Hello, Vijay sir.
I think
I
Vijay
think
is
you're, yeah, muted.
Ramesh.
Okay, so yeah, Ramesh has a question. I want to know about growth of mechanical engineers in designing field in industry wise, apart from masters, and what type of skills mostly to focus on. Because okay, yeah, that's perfect. In fact, I'm actually going to start as a mechanical design engineer for Tesla in just about 2-3 weeks actually. So. Yeah, let's answer those two questions. So I'll answer Ramesh's question first. Um, if you had to focus on skills, right? So think about there's a concept called DFM, right? Design for manufacturing. So what that means is while you're actually designing these things, I can design the most, for example, I can design something like this, in CAD. I can do the most crazy designs in CAD, whatever I want to do. But is it manufacturable? You know? So there are all these concepts of design for manufacturing, design for product design and things like that. So what you have to understand as a design engineer is you are, let's say, at the center of, this whole nexus, and you have to constantly keep interfacing with a lot of other engineers. So there will be a manufacturing engineer who will come and say, sorry, Ramesh, I cannot, manufacture this. The CNC will not allow me to manufacture, such a complicated design. So change your design, you know. So think about a holistic perspective of what sort of skills you should develop in general. I mean, obviously, all the CAD software and everything, that is a given. You should definitely, keep practicing as much as you can in CAD. Try taking the tutorials online. Uh, Start thinking about when you say design, we only keep thinking about structural design. But for example, when we design our heat sinks, what tends to happen is we need a certain thermal performance from that heat sink. So there's a lot of other factors that go into it. So it's not just the structural mechanics that go into it, but is it whatever I'm designing, is that actually going to give us the right kind of performance in terms of, let's say, heat transfer or fluids and things like that. So skills would be to give you sort of actionable advice, focusing on something that you see around you. If you have access to a CAD software, go out and just design, for example, your webcam. I have a webcam. Just design the entire webcam in CAD and see why they're doing what they're doing. There is a webcam, it needs to be mounted, it needs to have a certain aesthetic, and start thinking about why they're designing a certain things a certain way. I have a fancy mouse if you guys want to look at that. Oh, sorry. Let me change that. Why? And that is something called product design, right? This is a mouse like this. The reason, and this is a very standard mouse, regular mouse. But oh yeah, see, Varun sir has that ergonomic mouse. That's very cool. See, so why do they do that? Because this gives us a very nice, comfortable fit. I mean, I do this every day on a day-to-day basis, so I don't want that carpal tunnel, right? And Varun sir is essentially doing the same thing. So what are all the things that go into the design of a product? Start thinking about things like that. And I think that will allow you to, get better at design. For example, Apple iPhones and everything, they're so very well made, right? Why are they, they look so good? There's a product design and then there's industrial design and things like that. Anyway, I know we're running out of time, so I'll quickly answer Vishnu's question as well. Based on your journey, how does one decide between pursuing an academic career or transitioning to? That's a very good question. So uh, if you would have asked me during my master's what I wanted to do, I would have absolutely said that, I want to become a professor. I want to go out and teach, and I want to get into academia and all of that, because the fundamental research that I was doing, it was really giving me a lot of happiness. And, I really like that. And, to answer it in one sentence, the thing I would say is, it really is, sort of listening to yourself. But along the way, what happened is I did a lot of internships, and I realized that more than teaching people and more than doing this sort of this sort of a job of teaching, I actually started enjoying building products a lot more. So that's where I actually made the shift somewhere between in the second year of my PhD is when I realized that actually more than teaching, I was actually teaching in the university as well. I was a teaching assistant and I was actually giving lectures and all of that. But I realized that little bit more than that, I actually do enjoy building products. So there's no right answer to this. There is, it's about as you go along the way, you will realize so many things for yourself, right? transitioning to industry after graduate studies is fairly easy. I wouldn't say it's actually, in fact, actually becoming a professor is slightly harder because there's a lot of metrics that you need to focus on, especially after graduate studies. You need to have publications. You need to have, I mean, basically, for example, right, like I can, maybe get away with not knowing some concepts at a fundamental level. But the people who are teaching you, they cannot get away with that, right? They need to know if in a class, let's say you're asking, okay, sir, what is the, convection term in Navier-Stokes? I cannot say that I don't know. I am teaching you, so I should know that. So in fact, becoming a professor is slightly harder, I would say. So that decision is extremely personal, Vishnu, I would say. And the only thing I can tell you as advice is keep trusting, what you feel. At different points in time, you might feel differently, right? For example, I was, doing fluids, but then I wanted to do heat transfer. So at every point in time, be open enough to, try and shift fields if you want to. And there's no harm in trying things out. You try things out. Okay, if they don't work. For example, my first project was on oswald ripening, and I tried it out, and I didn't really like the emulsion thing. So then we switched to oil spills. So just keep trying things out. Your own heart will tell you whether you like it or not, and then trust your gut and say, okay, if I don't like it, then I don't like it. It's the same as food, right? Sometimes. I really like the egg fried rice in D1 or D2. But then the Maggi stall came. So then, we switched to the Maggi stall and we stopped eating the fried rice in, the canteen. So it's like that, basically. It's about trying things out. Oh, actually, dosa was better than Maggi. But so anyway, things like that, be open to things and just try things out. I think that's where you'll get your answer. I know we're way beyond time. I'm really sorry to keep you all, probably, stopped from eating dinner and all of that. But I have to tell you, it's been a very rewarding experience overall. I think BVRT provides you an extremely excellent platform to explore whatever you want to explore. You know, uh, keep doing what you're doing, keep exploring these things. And, there's a huge network out there, me included, who are just ready to help you in whatever dreams you want to pursue. So don't be held back, and feel free to at any point in time reach out. I want to be even more involved, and there's a lot more people who are involved. One of my friends from ECE, he was in my bus in BVRIT. He did his PhD. He actually pursued an academic career. So maybe I should reach out to him. Madhav Sharma, he's in EC, but so not exactly mechanical, but maybe, the next talk or something like that can be him, and he can explain why he decided to pursue, a professor, track, after his graduate studies. So just keep, this is also good, right? Like you're attending, um, these workshops and getting other people's opinions. That is one big step to figuring out what you want to do, because you get opinions of all the different people. So yeah, it's been very rewarding. Sorry, Dr. Varun, I'll let you give any concluding remarks, I guess.
Yeah, so thank you very much, Dr. Suhas. And I think this is very much needed where students have, as you can see, initially they hesitated, but they were very particular about the questions and the way they also tried to explore based on the inputs that you have given. And I must say how you have transformed. Like I could see how you were engineering days, and then the way you are giving the analogies and then trying to express in a best possible way. And slowly, the expertise that you have achieved in terms of convincing or maybe giving an example, and how composed you are in executing the thing. So I think that is a good quality that we are all able to see and notice how you transform basically. and on the behalf of all the mechanical engineering faculty who are here, and also the thermal stream, I think they are all excited to see the work that you are doing, especially Mullikrishna
Yeah.
sir, Reddy sir, and also Hardy sir is also here, and I can see a lot of our faculty members who are really happy to see your growth and progress. And in fact we are waiting to see you at Tesla, and I hope you have a very good career path. And on this note, I must convey my thanks to all the efforts that were kept in bringing this up, because I know you were mentioning that you have a lot of other commitments for Tesla, as well as you need to some closing things at universities is happening, and you had to prepare the PPT and all. But with your permission, what I request is, can we upload this video, the recording, so that others also, so other students will get benefited. And we are going to do such series hereafter. And definitely we can invite some of your colleagues, and also we can see who are all there in US, and also we'll have similar session. And I will request the students also to keep in touch, because our alumni is our strength,
Yeah,
and we can.
absolutely.
I also was trying to recall why VC sir was insisting your name, and why sir was mentioning that somehow we need to invite you to our institute, and then get the exposure. So this is the very reason why he was suggesting your name when you were expected to visit last year, if I
Yeah.
am not.
Actually, even this year in June, actually. Yeah.
Okay, acha,
June.
24th,
Yeah.
right, right.
Yeah. Yeah.
So let's hope that this time when you visit India, do visit our campus, and then let's see we can have any collaboration. So we can also talk on these things, but in short of time, what we'll do is, like, we'll end the session here. But definitely,
Yeah.
this is not an end. This is going to be a new beginning, and let's see that we have many such interventions, and you can guide our students, and then we can have any collaborations possible, right? So thank you for,
Definitely.
yeah,
Yeah.
please, any closing remarks?
That's it. I mean, I just want to say thank you to all, the faculty. I see a lot of familiar names here, Padma Rao sir, Hadi sir. In fact, one of the best things I still remember, one of the, really happy moments for me was when I published my first paper or second paper. I emailed, Hadi sir and basically Murli Krishna sir, because, they were, heat transfer and thermodynamics anyway. So, I don't think, without that sort of foundation that you have built for us, we could have, any of us, could have come here. So I really thank you. One thing I would say to all the students is you really have a great opportunity in terms of faculty. I know, how much efforts the management and the department is sort of putting in to recruit the best, faculty, to create the best resources for you. And I am, you can see right now, right? Probably, the department has only grown from 2017 to now in many different ways. And if I'm the product of the same, are actually slightly low, lesser resources, you have more resources. So if I can do that, you guys can absolutely, do much more. And again, I think as Varun sir said, we are all here to support you. So feel free to reach out at any point in time. And for me, it's definitely a very rewarding experience. Thank you for even giving me this opportunity. Yeah, thank you, sir. And thank you, Wasim sir, for even organizing and all of that.
Yeah, I want to conclude. Suhas, can you just stop sharing your screen
Yeah,
so
sorry.
that we are
Absolutely.
able to see you properly, because I think it's taking more bandwidth.
Yeah.
So, Yeah. So as a formality, so thank you, Suhas, for delivering a wonderful session. So what you said, your product of BVRIT, definitely it will be very motivating to the current students. Maybe they are somewhat hesitant to open up. Maybe in one-on-one session, it might be in the future they may open up in a broader way.
Yeah.
You have all qualities of becoming a professor. So definitely we will be inviting you for a guest lecture. Maybe on.
Sure, sure.
Thank you, Suhas. For just delivering a session to the students, and even for the first year students who have joined, so slightly edging, not going to do too deep in a technical way, and explaining what you have done. So actually that's a great presentation and delivery. Thank you. And mostly in the coming future, we'll be having such sessions with your classmates. Maybe I have identified a few from your batch. Maybe it is Surya. We have Kanaka Lakshmi. We have Mahalakshmi, right? Yeah. So we have 2 to 3 identified alumni. So we'll see you at that time, and be in touch. And thank you for your time as well as this session.
Yep. Thank you. And sorry to keep you away from dinner for so long. Try that drop thing on the dosa pan when you can.